This is AWS On Air at Remars, and this is the last of our Startup Spotlight series here. And we have the folks at TuSimple. My name is Jillian Ford, and I'm a Startup Solutions Architect. And I'm here with my amazing host.
Always it's amazing. That
Always,
you
you're so amazing.
It. I'm Am Grabelny. I'm a solution architect here at AWS as well. Also an on-air host, but the people of the hour here. TuSimple. Tom and Robert, please take it away. Introduce yourselves.
Hi, I'm Tom Wong. I'm the Director of Engineering at TuSimple.
Hi, my name's Robert Rossi. I'm the Vice President of Maps at TuSimple.
Yeah, so tell us, what is TuSimple?
Okay, so TuSimple is a leader in the developing autonomous trucks, okay? So to give you a little bit of background, in the United States, there are 2 million trucks on the road right now, driving on around 48,000 miles of interstate, okay? And the trucking industry is an $800 billion industry, okay? Of which 600 billion of it is long-haul container freight movement, okay? So we're addressing that portion of the industry and addressing one of the biggest problems, which is there's a driver shortage. Okay, there's not enough drivers to drive the trucks. So we're addressing this by developing autonomous driving technology for semis, okay? So in general, we're revolutionizing the freight transportation logistics industry in general. Our core product and our service model is something we call the AFN, the Autonomous Freight Network, okay? So in addition to the autonomy capability in the trucks, we have a nationwide network that we're beginning to build, okay, to coordinate the movement, to provide the terminals, to provide all the support, and then, of course, the information technology in the cloud, right, to support all of the vehicles that will be on the road. In the next several years, we hope to have 50,000 vehicles driving in this network.
You know, Robert, Tom, you may not believe this, but for a period of 6 months of my life, I was actually on an engineering team for a logistics trucking
Wait, so
software.
you know the Indians.
Kind of small world here. This was a long time ago. But during that brief stint on that team, I learned that the trucking industry is complex. Incredibly complex.
Absolutely.
Yeah.
Like scheduling all of these drivers. You mentioned 2 million?
2 million trucks are on the road, and then there's 5 million trailers. Right.
Yeah.
And
getting them to where they're going. That's a big deal.
And then you have the coordination of what happens at the port, what happens with rail interfaces, right? All the other different modalities of transportation, right? So you have to coordinate across all of those systems.
We've got you brought up the issue already of the driver shortage, right? Which I'm sure is on everyone's mind right now, especially when you go to places like the grocery store and things like that and see the empty shelves. What are the other reasons to build out autonomous trucks? One
of the big things is that fundamentally long-haul freight, if you look at the interstate, it's got long segments of straight roads. It's not really optimal for the human attention system, okay? It's really easy to lose your attention, and it's very difficult to aggressively maintain sustained attention on all your details when you're doing the same thing for miles and miles, and sometimes the scenery looks exactly the same. It's tough on the human mind. Everybody agrees with it. Secondly, it's a poor quality of life, okay? So for optimization of the network, you would go as far as possible, but the driver has to return home. Okay, right? So to have a good quality of life. So you have lower utilization of the trucks as a result, right? And you have a lower energy efficiency because a lot of times returning, the network is not symmetric, okay? So the demand, you might not be able to have a full trailer to come the other way.
Yeah, and I know earlier when we were talking last week a bit more about your company, you were saying that you were the first company ever to achieve level 4, autonomous trucking. So can you tell people about what that actually means?
Sure. So what the industry, the Society of Automotive Engineers calls level 4 autonomy is the ability for you to have a vehicle you could pilot, okay, but you can put it in a mode where it's fully autonomous, right? And it completely does everything, and you can use your attention elsewhere. You don't have to be ready to take over or anything like that. So level 5, it doesn't even have a cab or doesn't even have a steering wheel, okay? So our trucks go all the way from terminal to terminal. When we get in the terminal, we arrive at the terminal, then a human operator takes over to do the detail movement inside the terminal area.
Wow. Were you going to say something?
I know we've got some videos that we
Yeah.
want to see too. I think that's we could jump into that too. Maybe see what these trucks look like.
Sure. We're going to do 2 demos of the videos. The first demo will be about our driver out program, where it shows the level 4 autonomous driving. Okay. Whoops. Just a sec. There we go.
Introducing the TuSimple Autonomous Freight Network, AFN. A new transportation network making it possible for freight to move from point to point, safely and reliably, using autonomous trucks. The AFN begins with autonomous trucks powered by TuSimple software. These autonomous trucks travel along high-volume freight routes using digital maps, covering both highways and surface streets. Through an expanding network of mapped routes, autonomous trucks operate nearly continuously, transporting freight from one location to another. Along these mapped routes are a series of terminals we call launch pads. Launch pads are centrally located and serve as a start and end point for any mission. The AFN supports thousands of trucks at any given time, using a robust autonomous fleet operations platform called TuSimple Connect. The TuSimple AFN provides shippers, carriers, and fleets with game-changing operational efficiency, resulting in higher capacity, faster service, at a lower cost, while creating a new standard of safety in the process. The AFN offers 2 types of service: customer-to-customer service, C2, or terminal-to-terminal service, T2. C2 service is reserved for carriers and fleets who choose to own and operate their own fleet of autonomous trucks and require each trip to begin and end at their own facilities. For high-volume shippers, the customer's shipping facilities become their own private launch pads, enabling C2 autonomous operations. T2 service is best suited for lower volume shippers and carriers who require additional capacity. With T2 service, the trailer is picked up manually and transported locally to a nearby launch pad, where the trailer is linked to an autonomous truck and autonomously driven to the destination city. Once the truck arrives at the destination launch pad, the trailer is linked to a manually driven truck and delivered to the final destination. Whether you are a shipper, carrier, or a fleet, the path to better logistics has never been clearer. TuSimple, a better path forward.
So this is just like absolutely amazing, and I think a lot of people are just trying to wrap their head around like the engineering challenge that's actually being like you guys are like taking on. So I guess like one question that comes to mind is like I'm watching that is like how many years did it like actually take to get like your like build your MVP, right? I mean, I work with early stage startups, so I mean, an MVP has a very different definition than what an MVP in the autonomous trucking industry, right?
So let me handle this. So first of all, the company was founded by experts in computer vision in 2015. Okay, and there was a large research and development effort. The development of the first trucks, the accumulation of data that you need, right? And all of the establishment of the deep learning technology that's used extensively, okay? But it really took off in 2019, okay? And the 18-month stretch between 2019 and the middle part of 2020, okay, was the key catalytic area where all of the technology kind of catalyzed and came together.
Now, Tom, you had one more video too to show us, right?
Yeah, actually, my apologies. I actually played the wrong video, so I played the second video. I mean to be, the wrong order. So I have now we can play the video that demonstrate our level 4 driver out program.
Oh, great!
All right, so okay.
Founded in San Diego in 2015, TuSimple spent the first few years developing autonomous trucking technology that would allow Class 8 semi-trucks to autonomously drive from point to point over surface streets and highways with a safety driver behind the wheel. In December of 2021, TuSimple made history by becoming the first company in the world to successfully operate a semi-truck on open public roads without a human in the vehicle and without remote human intervention. The industry-first milestone not only positioned TuSimple as the clear leader in autonomous trucking, but proved we had the ability to automate a single high-volume freight route without a human in the vehicle. We had effectively become the first to achieve true Level 4 autonomous trucking. But the road to Level 4 autonomous trucking was a long one, filled with millions of miles of simulation testing, regeneration testing, hardware-in-the-loop testing, bench testing, track testing, and open road testing. In fact, we successfully tested our 80-mile driverless route between a rail yard in Tucson and a high-volume distribution center outside of Phoenix hundreds of times, perfectly, without disengagement and without human intervention, the test without a human driver in the vehicle. Our groundbreaking driverless achievement was the culmination of thousands of hours of software and hardware development and testing, and can be attributed to the unrelenting dedication of the entire TuSimple team, who wake up each day to help make autonomous trucking a reality. We believe AI-powered autonomous trucking will help make our logistics system safer, more efficient, and more environmentally friendly. And this is only the beginning. TuSimple, a better path forward.
Take it away, Tom.
All right, Tom, I've got to ask. I'm seeing some things on the trucks. Robert mentioned the autonomous freight network earlier too. The tech behind both of these things. So the actual tech on the vehicle, and then this network that it connects to. These have to be different to build, I would assume, right? Different concerns, different approaches. Can you break down some of the tech challenges or things you thought through on both sides, right? The actual devices on the trucks, and then where is that AFN running? What kind of things is it solving for?
Sure, yeah. So we really have two categories of technologies. So we have our self-driving tech stacks running in our autonomous trucks. We also have lots of backend services running in the cloud. In this case, it's AWS, right? So AWS has really been a game changer for us. It has been an indispensable partner of our success in the past few years. As a company, TuSimple is working on the cutting edge technology in self-driving technologies, right? The self-driving market is incredibly competitive.
Yes.
So time to market is the most critical factor to our success. Right. So AWS really provided us the robust and scalable infrastructure, that a foundation we can build on top of, that enabled us to develop our technologies much faster and is more cost effective for us. We also, AWS provides us both the computing and storage resources that we need to host our production environment as well as our development environment. So in a secure, reliable, and scalable manner. Right? We also were able to leverage the best technology network and partners that AWS provides us to integrate our solutions with our customers and partners as quickly and easily as possible.
Yeah. So just real quick, when you saw the video, we have to build technology that integrates with existing carriers and their IT systems, so they'll all be networked together, right? For this to coordinate and operate.
Yeah, when we saw that picture of the map, I mean, there were certain points that we saw that were highlighted. So could you just give at least the engineers a sense of what are some of the engineering factors that have to be taken into consideration when you're maybe going into a new city, a new part of the country?
So we have something we call the ODD, the Operational Design Domain. And at the beginning of the network, we picked a part of the United States that's particularly flat and the weather is good. okay? That gives you your easiest thing. You might have weird problems like tumbleweeds and things that are not in other environments, right? But the terrain is not hilly and steep, okay? You don't have bad rainy weather. You don't have snow, things like this. So you start off in a simplified domain, and you find business that you can haul, okay? And you perfect your technology stack to handle that environment. Then strategically, you have to build that network one node at a time, extending it, okay? And each time taking a reasonable step in complexity, okay, in the operational design domain.
Yeah, I would imagine a lot of things come up. You know, I'm not a trucker, obviously, but I drive on the highways and the freeways throughout the country all the time. You know, my car breaks down. I get a flat tire. There's a lot that you have to monitor on the trucks as well, too, I would imagine, and a lot of things to think through while you're building technology like this. What are some of the challenges that you all have faced that maybe were even unexpected? Like, hey, we didn't see this until we deployed it to this region, or you know, what are some of those challenges that you have to think through?
Well, one of the first one, I'll let Tom talk on the cloud side and scaling side. On the embedded side, the first problem you have is you need the latest and greatest technology, like GPUs, different kinds of compute resources, things like that. And right now, they're not mature for this type of application as an embedded system, okay? So you have, and they're certainly not designed for vibration, right? The vibration and the thermal and wattage aspects of what you have, right? So hardware reliability is been a huge challenge, right? We've got the software very mature, but the hardware reliability in the truck is a big challenge. Sensors like LiDAR that are very mechanical in their design, we really need that to become solid state solution for full resilience. And then Tom, maybe you can talk about some of the cloud and scaling type of challenges.
Sure. Yeah. So to solve some of the kind of resiliency or exception problems you mentioned earlier, so we're developing our AFN, Autonomous Freight Network, that I showed in demo earlier. So we're developing that as like a SaaS service hosted, running natively in the cloud. Yeah. So an example would be, so it gives us the ability to monitor a large fleet of our autonomous trucks in real time. So for example, our trucks will collect all the live events that they observe on the road and then send those events to our control center in the cloud, right? And then well, those the events are examples are construction zones, right? Accidents happening on the road, the lane closure, or their emergency vehicle parked on the shoulder of the highway, you know, those things. So those events got sent to the cloud and out to our control center. So our backend system can process those events and aggregate all the information together. And the results will then be shared back to all the autonomous trucks to help them make better and safer driving decisions. Right? So that's one example. So it forms kind of a closed loop between our autonomous trucks that could be running anywhere on the road and our control center running in the cloud. Yeah. So other things when it comes to scale, right? So we're doing our training our deep learning models in the cloud on AWS because we need a large pool of GPU resources. So AWS gave us that. So it's essential for us to train our models effectively to meet our business requirements, right? So then once we train those models in the cloud, those models will get deployed to our autonomous trucks, right? And then that's how help us make the driving decisions.
That's awesome. I mean, I don't know if you're much of a driver, Jillian, but I'm from Houston, Texas originally, and the scariest thing that's ever happened to me, washing machine on the freeway. Yeah. You know, but I didn't, I swerved, I avoided, but nobody else gained any insight from that event, right? But this is
in our case, an unknown object that's threatening would be communicated to a truck even seconds behind you.
Every truck learns from that one truck's experience of avoiding that washing machine, let's say, right?
Yeah, how should people learn more about TuSimple and what you're working on?
Well, they can go to our website. We have a lot of YouTube videos produced by the company. All the driver out missions were recorded on YouTube, so that's a good place to go.
Perfect.
And then, the rest, we have 2 social media sites on Twitter and Facebook. That's another place you can get information.
Thank you both for joining us, Tom, Robert, Jillian. Always a pleasure. Stay tuned for more on AWS On Air. We'll be right back.